All right, guys, we have the integral from -1 to 1 of arc cosine of x divided by 1 plus x squared dx. First, let's look at the bounds. We have -1 to 1. That's symmetric over 0. So the next thing we should look at is if this is an odd function. So let's check that. It's odd if negative f of x is equal to f of negative x. All right, so let's just write negative f of x. Just write a negative sign in front of the fraction. Negative arc cosine of x over 1 plus x squared is equal to f of negative x. So every time you see x, just plug in negative x. Arc cosine of negative x over 1 plus negative x whole squared. We can actually simplify the right side. This is going to be arc cosine of negative x divided by 1 plus negative x whole squared is just going to be x squared. And we see that we have the same denominators. However, this is left in the numerator. Negative arc cosine of x versus arc cosine of negative x. And we actually have no identity to prove that these are equal. So this function, this integrand, is in fact not odd. So we can't just say it's equal to 0. So our next step is to just analyze the function. What attributes does it have? Well, I can see a easily differentiable part of the function, which is arc cosine of x, and an easy integratable part of the function, which is 1 over 1 plus x squared. If I see one that's easy to integrate and one that's easy to derive, that suggests I can use integration by parts. So using the integration by parts formula, integral u dv equals uv minus integral v du. Let's choose our u and dv. U is equal to the easily differentiable one, arc cosine of x. Differentiating this, you get du is equal to -1 over square root 1 minus x squared. Now, let's do the dv. dv is equal to our 1 over 1 plus x squared, which is multiplied to the arc cosine of x. So dv is equal to 1 over 1 plus x squared. Integrating this, we get v is equal to arc tangent of x. Now, we multiply the u and v together for our first part. We have arc cosine of x times arc tangent of x minus the integral of v. V is arc tangent of x. And then du is going to be our -1 over square root 1 minus x squared dx. We can take out the negative here and the negative here and combine them to make a positive. So this is going to be positive integral arc tan of x divided by square root 1 minus x squared dx. And don't forget, we still have our bounds, -1 to 1. So we can actually put our bounds right here, -1 to 1, and also evaluate this from -1 to 1, just for our bounds, -1 to 1. All right, so I'm going to evaluate this first. So we have arc cosine of 1 times arc tangent of 1 minus arc cosine of -1 times arc tangent of -1. All right. And to this, we add the definite integral from -1 to 1 of arc tangent of x over square root 1 minus x squared dx. Let's look at this integral. Again, we have the -1 to 1 bounds. However, this is actually a different integral than last time. So how about we analyze if the function is odd or not, and we can just skip a bunch of steps and say it's 0 if it is odd. Well, let's check. We need to check if arc tan of x over square root 1 minus x squared is odd. Well, this is only odd if I set this to f of x. This function is only odd if negative f of x is equal to f of negative x. Negative f of x is simply going to be negative arc tangent of x over square root 1 minus x squared. And f of negative x is going to be arc tangent of negative x divided by square root 1 minus negative x squared. We can do a bit of simplification on the right side. This is equal to arc tangent of negative x. We actually know by a trig identity that arc tangent of negative x is equal to negative arc tangent of x, because arc tangent is an odd function. So we can change this arc tangent of negative x to negative arc tangent of x divided by 1 minus x squared. All right, so as you can see, this function and this function are equivalent. That means that this function is actually odd. Okay, so if this function is odd, that means that this integral will actually evaluate to 0. We can just cross this out of our answer. All we have to do now is evaluate this to get our final answer for our definite integral. Let's evaluate. We have arc cosine of 1. What value of cosine of x will bring 1? That's just going to be 0, 0. Arctangent of 1. What value of tangent of x is equal to 1? That's going to be pi over 4. Minus arc cosine of negative 1. That's just going to be pi. And arctangent of negative 1. Arctangent of negative 1 is simply going to be negative pi over 4. All right, evaluating this, I get 0 times pi over 4. That's going to be 0. Minus pi times negative pi over 4 is going to be negative pi squared over 4. 0 minus a negative is going to be 0 plus that. So 0 plus pi squared over 4 is going to give us pi squared over 4 as our final answer. So this integral is equal to pi squared over 4.